Hello, this is about percentage yield, okay? So the first thing that we're going to discuss is the idea that you've got a reaction, okay? And in this reaction, normally reactants turn into products. So if all the reactants turn into products, this is what we call 100% efficient, okay? So in theory, we should get all the reactants turning into products. That's 100% of it. However, in reality, this is unusual. Usually, not all the reactants turn into the desired product. This is what we call the actual yield. I'll show you an example now. Okay, so it's really important to focus on this idea of turning the reactants into products, okay? Now, based on the previous slide we looked at, it's all about the desired products. So it's the yield of the thing that you desire. So let's say we have this, iron add sulfur makes iron sulfide. In theory, okay, the theoretical yield, I should have created 100 grams of iron sulfide. But actually, I only created 80 grams of iron sulfide. My percentage yield would be 80, because that's my actual yield, over 100, times it by 100%, and that would be 80%. So my percentage yield of forming the desired product, iron sulfide, would be 80%. So the next thing we need to understand is why we might not get 100% yield. And the first thing I want us to think about is this idea of conservation of mass, okay? So this law is always true. You can never create atoms or just delete atoms. So this is not the reason why you have less product than you should, okay? You can't just delete stuff, okay? There is a real reason why you may not get 100% of your reaction. So let's say you have this much to start with of your reactants, and you form a product, okay? And let's say you form 4 grams of the product. This is your yield. This is your actual yield. Now, in theory, you expected to make, say, 8 grams. So this is your theoretical yield. So what we've not done, we've not just deleted atoms and lost atoms to nowhere. Okay, there's a reason that actually we've only got 4 grams, whereas we should have had 8. So let's look at those reasons. Well, the first reason is our reactants may have not reacted in the way that they were supposed to. Okay, so they may have done a side reaction, reacted in a different way than was expected, and therefore they would use up some of the reactants, creating a different product, a product that we don't desire. So the first thing, maybe we get a side reaction, or the reactants may react in a different way than expected. Okay? The next reason we may not get 100% is that some reactions take a really, really long time. For example, the rusting of iron oxide can take years. So if you were to stop that reaction early, not all of the reactants would have turned into products. So the second reason is the reaction may not go to completion. So this is the idea that all the reactants may not turn into the product, maybe because you didn't leave it for long enough, or more likely because the reaction is reversible. So that's this symbol here. So this reversible idea means that the products actually turn back into the reactants. So you may not get all the yield you expect, because the reactants don't all turn into the products, because maybe some products turn back, or the reactants don't all react. The final step, well, if you think about, we're trying to create this product here, we're trying to create a really pure product, a dry product, and you're going to have to go through lots of steps for this to happen. So you may have to go through the steps of filtering it, you may have to go through steps of washing it, and when you do those several steps, there's always the possibility you might lose some product. So even pouring two solutions together in different beakers, you're always going to get some product left on the side of the beaker that you're not going to be able to use. You're always going to get some product maybe left in your filter paper that you can't scrape out, so you're always going to lose some product. So the final reason is some product may be lost, and this could be in the purification stage.